here we have the first question in the objective test, and it says multiply 2.7 times 10 to the minus 4 by 6.3 times 10 to the 6, and leave your answer in standard form. The key thing in this question is getting your multiplication result to standard form. Everyone can multiply, but what this question is looking for is the steps taken to get your answer to standard form. And to start with, I'll just remind you or introduce to you what standard form is. So standard form is really the expression of a number in a form where it's in the form a times 10 to the n, where n is any real number. So n could be a negative number or a positive number or even 0, but I mean, that's standard form. A is just a number with only one digit before the decimal place. So A would be numbers like 1.17, 2.23, 3.38. As you can see, all of these numbers have only one digit before the decimal place. I think the next thing to do is just show you a simple example of converting a number to standard form. So say you were given the number 329 and asked to convert it to standard form. What would you do? I mean, you want it in this form, 10 to the n. So the technique will be just to maybe go to the last digit, so the digit to the right of the number, and can draw arrows moving back and count the number of times you kind of get a curve. So 1 and 2 in this case. And that, you're trying to get to the position where you only have one number before the decimal place. So, in this case, it'll be 3.29. And the number of times you move backwards is what n is going to be. And that's an easy way to do it. So I'll just do another example. 269 will be 2.69, and you just times 10 to the, and n is going to be equal to the number of times you have to move backwards from the last number. So 1, 2, 10 to the 2. So that's how you do standard form. So if you go back to the question, please note it down. 2.7 times 10 to the minus 4 by 6.3 times 10 to the 6. So I'll just call it solution now. Prior to actually carrying out the multiplication, I want to draw your attention to a useful law of indices that is going to be applied in this question. And it goes as follows. X to the n times x to the m is equal to x to the n plus m. So you should have covered this when you visited the laws of indices. And all this says is when you have a number or variable raised to a power times the same number of variable raised to another power, you simply have this form where you have that number of variable raised to the sum of the powers. So if you had 10 to the 2 times 10 to the minus 6, your solution would be 10 to the 2 minus 6. So you simply add 2 and minus 6. So I guess I should have done 2 plus minus 6, which is the same thing as 2 minus 6. And that's 2 to the minus 4. So that's just an example. So for the purpose of this question, we have 2.7 times 10 to the minus 4 times 6.3 times 10 to the 6. The first thing I'll do is rewrite this expression so I can group the 10s together. So I have 2.7 times 6.3 times 10 to the minus 4 times 10 to the 6. And I'll further even group the multiplication problem. So I'll have all the 10s together and all the other numbers together. The reason why I'm doing this is so that we can apply this law of indices, this one here, to the 10s because they have the same base. Remember, from the laws of indices, the number in this position is called the base, and this number is called the index or power. So when you're multiplying two numbers with the same base, you keep the base and you add the powers. That's really what that law says. And that's what I'll be applying here. So firstly, 2.7 times 6.3 is 17.01 times 10 to the minus 4 times 10 to the 6 is 10 to the minus 4 plus 6 according to the law I just showed you. So therefore we have this. That's a minus 4, by the way. So that's 10 to the 2. I mean, the question now is this standard form? No. Why? Because the number, remember, standard form is a times 10 to the n. We have the 10 to the n part. I mean, we have a 10 to the n part, but the a is not right because the a has to be a number such that it only has one digit before the decimal place. So just like I demonstrated before I started solving the problem, a number like 17.01 will be 1.701. So you times 10 to the, and n will be the number of times you move to get to the position where you have one digit before the decimal place, and that's just once. So it's times 10 to the 1. So therefore this whole expression here is essentially this. Oh wow, that happened. Times 10 to the 1 times 10 to the 2. And just before I simplify further, can I just point out that 17.01 has just been replaced by this, while the 10 to the 2 still remains as it was. So finally, we can apply the laws of indices once more, because we have 1.701, that's the number with only one digit before the decimal place, and then 10 to the 1 times 10 to the 2. So these are two numbers with the same base, but and different powers. So you just keep the base and you add the powers. So that's 1 plus 2. And finally we have 1.01 times 10 to the 3. Now that's your solution. That's the original expression given in standard form. That this is the solution. I just want to point out that for the law of indices, I mean, they're called exponent laws, and I prefer to call them that. For the exponent law shown here, the powers, so when you have numbers with the same base, the powers do not have to be different. So if you had numbers with the same power, say you had the number with the same base, say 10 to the 2 times 10 to the 2, the law still applies. You keep the base and you add the powers. 2 plus 2 is 4. So the key thing here is just the numbers having the same base, and it's important you know your laws of indices because they crop up in almost every area of maths. But there you go. Thanks for watching my video.